Hello everyone, it's Miss Maneely, and I'm going to go ahead through our quarterly assessment review packet for the third marking period quarterly assessment, which is next class. Remember that this assessment is worth 10% of your marking period grade and there are no retakes. So if you have any questions, please come in for Bulldog Block so that I can answer them. So this time I broke up the review packet so it would be in the order that we taught the content. So we've covered about 2 and maybe about a quarter of the 6th chapter. So Unit 4 was on probability, Unit 5 was on statistical analysis, and Unit 6 we've begun talking about trigonometry, which kind of reverts back to what you've already learned in geometry. We've only done the very beginning. So in the first problem, and this is a probability problem, and notice that because I've changed the order so it follows the order that we learned the content, I've indicated which problems allow you to use a calculator and which ones don't. So as I go through the review guide, I'll make sure that I emphasize which ones you can use a calculator and which ones you can't, and the kinds of things that you'll have to remember. So in the first problem, you're given a table. This is a two-way table, and it says that it is a record of those aboard the Titanic. So you can see who was in first, second, and third class, who was a member of the crew, and then the number of individuals who died and survived, along with all the totals, which is nice. So in letter A, it says, what's the probability that someone survived? That is the only condition that you're given. So we're just going to look for all of our survivals, which is along this row, and we have a total of 718. So the probability that someone survived is going to be 711 out of the total, which is 2201. Since this is a calculator problem, you can find the probability simply by dividing. So if we take 711 and divide it by 2201, that gives us a probability of 0.323. I'm going to give it, and actually let me go ahead and just adjust the screen here so that you can see the calculator at the same time. Okay. And then in letter B, it says, what's the probability that someone was in second class? So this time I'm only looking at the individuals that were in second class, and I can see that there was a total of 285. So if I'm looking for the probability of second class, there were a total of 285, again, out of that same total of 2201. So if I take 285 and divide that by 2201, I have 0.129. So about 12.9% of the passengers were in second class. The third question says, what is the probability of being in second class and survived? And means that we're talking about an overlap. Let me do this in red. And means overlap. Remember, and the symbol that we use for and, if you remember, looks like this. It means an intersection. It's where they overlap, where both things occur. Or is a union, and it means one or the other or both. And I think there is a question in the next problem that deals with that. We'll go over the formula then. So the probability of being in both second class and surviving, I now want to make sure that I'm looking where both conditions are met. So this group of individuals right here were in second class and they also survived. There were 118 of them. Again, there's no other condition, so I'm still talking about out of the total. So the probability of being in second class and surviving is 118 out of 2201. Since it's already written in probability notation, you don't have to rewrite it. So we've got 118 divided by 2201. And the probability is 0.05 if I round that 3 up to 4. So 0.054, a little bit more than 5%. And then the next question asks, are the events second class and survived independent? Use mathematics to justify your answer. Well, there's two ways you can do this. You can look at the conditional probabilities and see if they change, or you can look at the probability of both. And basically, we have this rule that says if the probability of A and B is equal to the probability of A times the probability of B, then the two events A and B are independent. And in this case, the two events we're talking about is being in second class and surviving. Well, I've already found the probability of both. That's this first part. This is the probability of both. And the probability of both we said is 0.054. And the question is that equal to the probability of being in second class times the probability of being in first class, which was, probability of surviving. And so the question is, are these two quantities equal? So on my calculator, I'm just going to multiply the 0.129 times 0.323. And I get 0.04, that's going to round to a 2. But I can see very clearly that that is not the same as 0.054. So since those quantities aren't the same, the events are not independent. Okay. You can also just multiply the fractions together and see if you get the same answer that way. But this is a calculator. The first part of it is a calculator-based question. Letter E is not. It says, what's the probability that the passenger died given they were in first class? And you can leave your answer as a fraction. So remember, our conditional probability involves that given. So if I have the probability of A and then that slash B, B is the given piece. A is what I'm looking to try to find the probability of. So it's saying, what is the probability that the passenger died? That's going to be my event A, given that they were in first class. That first class is going to be my event B. So if I want to write this out, I'm going to write the probability that they died, given that they were in first class. Now, in terms of calculating the probability, if I'm given that they were in first class, then that is the only group of passengers I want to consider. I'm not looking at everybody on the boat. I'm only looking at the passengers that were in first class. So instead of dividing by the total number of passengers, I'm going to be dividing by the 325. And out of those, I want to figure out the number that died. And the number that died was the 122. And you can leave your answer as a fraction since you're not able to use your calculator here. So it would be that 122 out of 325 would be the probability that a passenger died given that they were from first class. All right, let's take a look at number 2. This is another problem where you can't use your calculator, so you are going to have to do some of the math by hand. In all of these, you can leave your probabilities as fractions. So in number 2, it says the local grocery store is enticing its customers with a grocery giveaway game. The table below shows the prizes that can be won and the corresponding number of winners. So if I add them all up, because I am going to need a total here, let's go ahead and do this. So we've got, I'm going to do my biggest number first, my 102, I've got 16, 45, and 3. And if I add them all up, I know my 2 plus 6 is 8, 8 plus 5 is 13. If I add another 3, that gives me 16. I'm going to carry the 1, that gives me a 6. So I have a total of 166. So if I want to find the probability of free groceries for a year, I'm going to take the number in that category, and there were 3 of them, and put that out of the 166 winners. And that's how I would calculate the probability there. In letter B, I'm looking for the probability of getting 20% off the next purchase or a shopping spree. So the probability of 20% off or a shopping spree. Remember, with or, we add. So I want to look at, and there's no overlap here, so I don't have to worry about like subtracting an overlap. We've got 20% off, which is going to be 102, and I want to add that to the number that can have a shopping spree. So 102 plus 16 is going to give me 118. So the probability that someone would win either of those is going to be 118 over 166. And then the last one says, what's the probability of not winning a $50 gift card? Well, I can add up all of those values, or I can simply do 1 minus the probability of winning the $50 gift card. This is the complement rule. And so it would be 1 minus, so the probability of winning the $50 gift card would be 45 over 166. And if you think about it, that 1 minus, well, the 1, you'd have to find common terms here, is the same thing as 166 out of 166 minus 45 out of 166. And if I subtract my numerators, I know 6 minus 5 is 1, 6 minus 4 is 2, so that gives me 121 over 166. Okay. Number 3 is calculator based, so you can use your calculator here. It says the weatherman says that there is a 42% chance of rain today. He says there's a 50% chance of rain tomorrow. The chance it will rain both days is 15%. What is the probability that it will rain either day? There are 2 ways you can do this problem. I think in this case, we might as well just go ahead and use our probability rule. If you think about it, so we're given the probability of rain today. So the probability of rain today is 42%. I'm going to leave it as 0.42. 50% chance of rain tomorrow is equal to 0.5. And the chance it will rain both days, that means probability of today and tomorrow is equal to 0.15. And we want to find the probability that it will rain either day. Either means or. So we want to find the probability of today or tomorrow. And we have a rule for this. I'm going to give myself a little bit more space. If I call rain today, let's go ahead and call this event A, and rain tomorrow event B, then the third one is going to be the probability of A and B. And I'm trying to find the probability of A or B. Well, we have a rule that says the probability of A or B is simply the probability of A plus the probability of B minus the probability of both A and B. Well, these are just the probabilities that you're given in the problem. The probability of A, or rain today, is 0.42. The probability of B, or rain tomorrow, is 0.5. And the probability of A and B, or rain both days, is 0.15. This is a calculator-based question, so you can simply add 0.42 plus 0.5 minus 0.15. And we get 77%. Okay, I think that's the best way to do this problem. You could set it up with Venn diagrams, but I'm afraid if I show you 2 different methods, it'll just be more confusing. This rule is written on the wall, so you can use that rule to solve this problem. Okay, that brings us to our next unit on statistical analysis. So notice number 4 is a calculator-based question, but you don't need a calculator to answer it. And that's kind of how it is with some of these questions, that the problems that are on the calculator section, you don't really need a calculator. It seems kind of unfair, but that's how it is. So in number 4, it says to explain the primary difference between an observational study and an experiment. Remember, there's 3 different ways that we can collect data, essentially. We've got observational studies, experiments, and simulations. In an observational study, we're simply observing. We're not changing anything. I am collecting information. I'm trying to find what is going on. Now, I could, prick somebody's finger and draw blood. I could give them a IQ test or an SAT test, but I'm just trying to find baseline scores. I'm not changing anything. That's an observational study. An experiment is when I'm imposing what we call a treatment. And I'm deliberately doing it on purpose to change a variable and then measure the reaction. So that's the primary difference. In an experiment, a treatment is imposed. And what that means is we are deliberately changing a variable. To measure the reaction. And if all else is controlled, so if I control all the other variables and I use randomization, an experiment is the only way I can determine cause and effect. So that might be something else you want to add here. In a well-designed experiment, causation can be established. I can't establish causation from an observational study. So we had an example, I think, in one of our quizzes where we had like administrators looking at the success of, I think it was like a SAT prep class. But they were only looking at the kids that had already enrolled in the course and their SAT scores. Since the administration didn't put them in the class, they couldn't justify causation here. So in an experiment, the researcher has to impose a variable or impose a treatment and then measure the reaction in order to be able to establish causation. In number 5, you're given 3 different box plots, and they show the average daily temperature for each month of the year for 3 cities. And we're looking, it looks like Tucson, Seattle, and Boston. Okay, and it says which city has the least consistent temps or temperatures and why? Well, what does it mean to be consistent? Consistent would mean very low variability. There's not going to be a lot of changing around. So least consistent would correspond to low variability, and that would correspond to the spread. Well, there's 2 ways we measure spread. Well, actually, there's 3 ways we measure spread. We talk about the range, the interquartile range, and the standard deviation. When you're dealing with box and whisker plots, you can capture the range. The range is simply going to be the distance or the difference between the max and the min. That's your range. The interquartile range, then, is just going to be the length of your box. And so it is possible that if you consider the range, it may be one value might be most consistent, and the interquartile range could say otherwise. They don't always have to jive. In this case, however, I think it's pretty obvious that in both cases, Seattle has the has the most consistent. I wrote this backwards. I'm sorry. Least consistent means it's not going to have very much. Let me start over again. Consistent means that there's low variability or low spread. So if we're looking for something that is least consistent, it's actually going to have high variability. I apologize that I worded that funny. Consistency means that there's not a lot of variability. So if it's least consistent or low consistency, it actually means that there's going to be a lot of variability. If something's not consistent, that means it's constantly changing. And so if we're looking for the temperatures that are constantly changing, whether I look at the range or the interquartile range, I think it's pretty obvious that Boston has the highest consistency, or has the, I keep saying it backwards. Boston has the highest variability. I spelled that wrong. Variability. I still spelled it wrong. There we go. That means it has the largest range and the largest interquartile range. Okay, so either way you look at it, Boston has the highest variability, which is the same thing as the least consistency. It's the least consistent. It's changing the most. Okay, in letter B it says Sarah is looking at colleges in each of the 3 cities. She likes cool weather, and cool weather would correspond to low temperatures. If she selects a college based on the average daily temperature, in which city should she choose to apply to college? Explain your reasoning. So if she likes the cooler temperatures, that means she's going to like lower temperatures. And if we're looking at like averages, it would be most beneficial probably to look at the median. And again, Boston has the lowest median. It also has the lowest minimum. So it's going to have the coolest temperatures on average. Okay, so Boston has the coolest temperatures, and it also varies the most. I don't know why I'm having such a hard time spelling today. Okay, and so this is a problem where you want to make sure that you, if it asks you to explain your reasoning or to justify your reasoning or to explain why, that you do that, because this is most likely going to be a multi-point problem. And if all you do is say Boston and it's a 3-point problem, you're probably only going to get 1 point. So be careful because these tests usually don't have a ton of points. In number 6, this is another one where you can use a calculator, but you don't need it. So in number 6, it says to consider the histogram of salary data for a large company. It says to describe the shape. I think very obviously this is not a symmetric distribution. It's very clearly skewed. And remember, when we're describing the skew, we want to describe where the tail is pointing. So in this distribution, we are skewed to the right. And it says to compare the mean and the median salary. Remember, the median is always in the middle. It's not going to be affected by skewness. It's not going to be affected, that looks like an outlier. It's not going to be affected. But the mean will. That means that the mean is going to increase. And so the mean will be greater than the median. And remember, we said when it's skewed to the right, the mean is high, or higher than the median. And then in letter C, it says which measure of spread would be more appropriate, the standard deviation, or, that should say or the interquartile range. Well, if a distribution is skewed, you need to remember that the mean is screwed up, so we don't want to use it. If a distribution is skewed, we use the median. And the measure of spread that corresponds to the median would be your interquartile range. So we'd want to use the interquartile range with the median for skewed distributions. And we'd use the standard deviation with the mean for symmetric distributions. Okay. All right, and number 7, this is another one that is a non-calculator question, but you are going to have to do some math. So it says in number 7 that the height of students at a school follows a normal distribution with a mean of 1.4 meters and a standard deviation of 0.15 meters. It says to show the distribution of heights using the normal curve below, and then be sure to scale the axis appropriately. So remember, our mean is in the middle. That means that this value right here is going to be 1.4 or 1.40. And then every one of these marks up and down, I'm going to scale it according to my standard deviation. So let me go down first. So if I have 1.40 and I subtract 0.15, so that's going to give me 5, and then, so we've got 1.25. If I subtract another 15, that's going to give me 1.1. If I subtract another 15, that's going to give me 0.95. Okay. Adding 15 is probably going to be a little bit easier. If you think about this as $1.40 and I'm adding 15 cents, this would be $1.55. If I add another 15 cents, that would be $1.60, $1.70. And another 15 cents would be $1.85. So that might be another way to think about it, so it makes a little bit more sense. And we're dealing in meters. So I'm going to scale my axis and provide units as well. So that's what you're asked to do in letter A. In letter B, it says, between which values will 68% of students fall? This corresponds to our empirical rule. I know that in the middle, that's my median, so I know half of the data is going to be below and half of it's going to be above. 68% of my data is going to be between the first standard deviations. That's 68%. And so I can say between 1.25 and 1.55 meters. If I want to know the values for which 95% of my students are going to fall, I'm going to go another standard deviation away. So this is 95%. So that would be between 1.1 and 1.7 meters. And then the third standard deviation would correspond to 99.7%. Okay? So basically, anything beyond, if you think about these areas here, those are going to occur less than 5% of the time. So less than 5% of my population is going to be less than 1.1 or more than 1.7. And remember how we said that 5% kind of tells us whether or not something is considered unusual or exceptional. So if I look at Charles, it says Charles is 1.715 meters tall. Well, where does Charles fall on this scale? 1.71 is right about here. This is Charles. And because he falls 2 standard deviations away from the mean, his height is going to occur in less than 5% of the population. So he would be considered exceptional if we use that 5% gauge. So since Charles's height is beyond 2 standard deviations from the mean, his height occurs in less than 5% of the population. This makes him exceptional. Oops. Okay, because if it happens less than 5% of the time, we say it's very unusual or it's exceptional, and his height is. All right, and number 8, we are allowed to use a calculator. Mensa, which is the largest high IQ society, accepts SAT scores and scores from traditional IQ tests to determine membership based on intelligence. So if we assume that the mean combined SAT score is 1,500 and the standard deviation is 300, so if we're talking about the SAT, we know that the mean is 1,500 and the standard deviation is 300. And we know that Jackie got a combined score of 2,070. We have another test, an IQ test that I guess Marla took, and it's a traditional IQ test. And we know that Marla got 129. Or Maria, sorry, I can't see my screen. That makes more sense. Maria got 129. And on that test, we're told that the mean is 100 and the standard deviation is 15. Okay, so it's hard to compare the two scores because the distributions are so different. So what we do here is we standardize the scores and we calculate what is called the z-score. And the z-score is just equal to whatever the value is, so whatever our observation is, minus the mean over the standard deviation. And in symbols, a lot of times that looks like x minus mu over sigma. And so what we want to do is find the z-score for each of these ladies. So for Jackie, her z-score is going to be the 2070 that she scored minus the mean of 1,500 divided by 300. Now be careful, if you're going to do this all in one step, you want to make sure you put parentheses around your numerator. So if we take 2070 and we subtract the 1,500 average, close my parentheses, and then divide by 300. And it gives her a z-score of 1.9. So she's not quite 2 standard deviations above the mean for those who took the SAT. Let's check out Maria. Her z-score, I'm going to take her IQ, which is 129, and I'm going to subtract the mean, and then I'm going to divide by 15, which is the standard deviation. Again, I'm going to put that numerator in parentheses. So 129 minus 100, and I'm going to divide that by 15. Okay, and we get 1.93. Okay, since both of these values are positive, we can see that Maria is higher above the mean. So she's more intelligent. And that would be then Jackie. Okay. All right, our last section deals with periodic functions, and this is what we just started learning. In number 9, it says to give the value of each coterminal angle. And if you remember when we first started talking about angles, we said that if the initial side lies on the x-axis, that is considered our initial side. The terminal side is the other ray. And so if you take a look at this first angle, since it's positive, I'm referring to that part of the angle. If I want to find the other angle associated with it, I need to go the other way and rotate clockwise. And if I rotate clockwise, that means that that angle is going to be negative. And the way I figure that value out is to simply subtract 50 from 360 because together they make up the circle. So 360 minus 50 gives me a value of 310. So this other angle is going to be a negative 310 degrees. In letter B, notice that we're given this angle, which is negative 65 degrees. If I want to find the coterminal angle here, I'm going to go counterclockwise around. And that's going to end up giving me a positive value. And again, if I just find the difference, now this time since since 65 is negative, I'm going to add 360. And this is really what we were doing before. Okay, and we get 295. So this angle is 295 degrees. All right, so number 10, this problem is non-calculator, and I do want to kind of review a little bit about logs. I know we didn't spend too much time on it, but if you remember, if I have, for example, the log base, I don't know, let's say 3 of 9, and I'm trying to figure out what that equals. When you have a log, we basically can rewrite it as an exponential by looking at the base. We always start with the base. The base is the base is the base. So that means when I change this to an exponential, and think about what an exponential looks like. That would be what an exponential looks like, where I have my base raised to a power equals a number. Well, I just said that 3 is my base, so that's going to go here. And because the log and the exponential are considered inverses of each other, I can switch the x and the 9. So the 9 isn't going to be on the same side as the 3 anymore. This is going to become an x, and on the other side I'm going to have a 9. And so I'm essentially thinking 3 to what power is equal to 9? And I can figure that out, and I know that x is equal to 2. So the log base 3 of 9 is 2. If I had something like the log of, I don't know, or the log, actually, let's do the log of 100. If you look at the log of 100, it doesn't have a base. So you need to remember this is a common log. And if it's a common log, that means the base is 10. So I'm thinking 10 to what power gives me 100? That again will be 2. If you notice, you've got the natural log of e. That's what that ln is. The natural log is another one of those, one of the logs that we talk about. It also has a base e. So if I have the natural log base e of e, then I'm thinking basically e to what power gives me e? Well, the answer would be 1. Anything raised to the first power is going to be b itself. Okay, and so that's actually going to be true for any base. So if I'm dealing with something like the log, let's just say base, let's just call it n, the log base n of n, if the base and the argument are the same, it's just going to be 1 because the base to the first power is going to stay the same. It's not going to change. So notice here we have the log base 6 of 6. Since the base and the 6 are the same, I know my answer is 1. The natural log of e, we already figured out, is just 1. So you don't need a calculator for this. The other 3, this is where you're going to want to use your unit circle. So let me pull that up. Okay, so I pulled up my unit circle. I'm not going to flash the whole thing. But in letter C, it says, what is the tangent of 3 pi over 4? So this is where you want to remember your either Sohcahtoa or you want to remember your relationship. And I don't have a ton of space, but let me do this on another sheet. So we said last class that the cosine of theta is going to correspond to our x-coordinate on the unit circle. And the sine of theta is going to correspond to our y value on the unit circle. The tangent is just going to be the y value over the x value, and then we simplify. So let's go back to the tangent of 3 pi over 4. So I'm going to find 3 pi over 4 on my unit circle, and I've got it right here if I can get it. Whoops. Okay, so, whoops. So 3 pi over 4 is this quantity over here. So we've got the negative square root of 2 over 2 and positive square root of 2 over 2. I wish that didn't disappear like that. So my x-coordinate is a negative square root of 2 over 2. So let me just write these down. Negative square root of 2 over 2 and positive square root of 2 over 2. So if I want to find the tangent, I need to do my y value divided by my x value. Well, notice that the values of x and y are the same. They're both the square root of 2 over 2. One's positive and one's negative. So I'm essentially, this is what I'm trying to figure out. The square root of 2 over 2 divided by the square root of 2 over 2, except the x value is negative. Well, these values are going to cancel each other out. Anything divided by itself is just 1. Since one of them is negative 1, or is negative, when they cancel, they're going to cancel to a negative 1. Okay. Otherwise, you'd want to multiply by the reciprocal, and I'd flip the bottom fraction. If I think about the sine of negative 30 degrees, okay, so let's take a look at our unit circle again. Okay, I know that a positive 30 degrees, I'm going counterclockwise and I'm going up. A negative 30 degrees is going to be the same distance, but it's going to be going in the other direction. So a negative 30 degrees is going to correspond to a 330 degree angle, and the coordinates for that are going to be right here at that negative, it's the square root of 3 over 2 and negative 1/2. So let me write these ordered pairs down. So it's going to be the square root of 3 over 2 and negative 1/2. If I want to find the sine, remember we said the sine is simply the y-coordinate of that point. So the y-coordinate of that point is just negative 1/2. Let's think about the next one, the cosine of 4 pi. 4 pi is not on my unit circle. So you could change this into degrees, but you're not allowed to use a calculator on this. So let's think about what 4 pi means. Let's go back to our unit circle. So in my unit circle, if I start at 0, and I go halfway around the circle, I get pi. If I go all the way around the circle, I'm at 2 pi. If I go around again, I'm at 3 pi. And if I go around a whole 2 revolutions, I'm at 4 pi. So at 4 pi, I'm at this is the same angle as 2 pi, which is the same angle as 0. And so if I think about the ordered pair that is associated with that, it's the ordered pair 1, 0. And if I want the cosine, remember we said the cosine is just going to correspond to the x value. And the x value of this ordered pair is simply 1. So notice you have some of these answers are just equal to 1. In number 11, this problem actually requires that you construct a triangle. And it also expects you to remember Sohcahtoa. There was a typo on your paper when it came out. I believe it said, given the cosine of theta is equal to 12 over 13. And then it says, if theta lies in quadrant, I think on your paper it says quadrant 2. That should actually say quadrant 4. And then it asks, what is the value of sine? Well, let's first of all set up a triangle. We said that the cosine, if I think about cosine, think about Sohcahtoa. So let me draw a triangle here. If this is my theta, and this is the right angle, I'd say that this is my opposite side, this is my adjacent side, and this is my hypotenuse. If I think about Sohcahtoa, it starts off with the sine. The sine would be equal to the opposite over the hypotenuse. When we get to the Sohca, we're talking about the cosine. And the cosine is going to be the adjacent over the hypotenuse. And then our toa is going to be opposite over adjacent. Okay, so hopefully you guys can reconstruct that at this point, since this is something that you did in geometry. So let's go back to our example. We're given the cosine of theta is equal to 12 over 13. Well, think about Sohcahtoa. That means that 12 has to be the measure of my adjacent side, and 13 has to be the measure of my hypotenuse. So if I were to draw a triangle, this is theta, and I know that my adjacent side is 12, and my hypotenuse is 13. Please note that this is a no calculator problem. And notice the numbers here. You have to use the Pythagorean theorem. This is my unknown. That means that x squared plus 12 squared is equal to 13 squared. You have to be able to square these numbers without a calculator. So x squared is obvious. 12 squared, if you can't remember what 12 squared is, then multiply 12 times 12 and do it by hand. 2 times 2 is 4. 2 times 1 is 2. I bring down a 0, and then I multiply by my 1. So 1 times 2 is 2. 1 times 1 is 1. When I add them together, I get 144. Okay, there is an expectation that you guys have these perfect squares memorized. 13 times 13, same thing. We're going to do 3 times 3 is 9. 3 times 1 is 3. If I bring down my 0, now I multiply through by 1. 1 times 3 is 3. 1 times 1 is 1. And when I add everything together, I get 169. If I want to solve for x squared, I have to subtract 144 from both sides. So I get that x squared is equal to whatever 169 minus 144 is. So we get 25. And that works out really nice for us because 25 is a perfect square, and when I take the square root of both sides, I find that x is equal to 5. Now that gives me the missing side, but it doesn't tell me the value of sine. I still have to do that. The sine of theta, remember, is going to be the opposite over the hypotenuse. And the opposite side now, we know, is 5 over 13. The very last thing that you have to consider is what the sign, whether it's positive or negative, of this value should be. And if our value is in quadrant 4, think about your quadrants. We've got quadrant 1, 2, 3, and 4. Sine corresponds to our y value. And so if I'm in the 4th quadrant, is my y value going to be positive or negative? And it should be negative. So you want to make sure you include a negative symbol there. In the last problem, it says to determine the radian measure of an arc whose central angle measures 130 degrees. All you have to do here is change 130 degrees to radians. So remember, if I've got my answer in degrees and I want to change it to radians, I need to incorporate pi. So this is when I multiply by pi over 180. In this problem, you're allowed to use a calculator. So if we pull up our calculator, I'm just doing 130. Oops, I didn't mean for that to take over. And I'm going to divide by the 180 since the 180 is in the denominator. I'm not going to include the pi symbol on my calculator. Now I get a decimal, but if I go to my math window, I can change that number back to a fraction, and I get 13 over 18. So when I write my final answer, I'm going to have my 13 and my 18, but I don't want to forget about pi. So I'm going to include the pi in my final answer. And I believe that's it. So if any of this was confusing or if you need some extra help, please come in for Bulldog Block and I will help you. Good luck.